Hey guys, welcome to Safi Mixed. In this video, I will let you know how to prove that cos function is an even function, that is cos minus theta equals cos theta, and sine function is an odd function, that is sine minus theta equals minus sine theta. Okay, this is quite easy, and to prove this, we consider the geometry of a circle. That is, I consider a circle of radius r. Let this be the center, and let this be the radius r. I consider my coordinate x's such that the origin of coordinates x's lies exactly at the center of the circle. I call this x and this y, and then I consider a point exact like this one, which makes an angle theta, and that is anti-clockwise rotation, that is in the standard position, it is theta, and let the values of the coordinates of this point be x1 and y1. Then x1 and y1 means that the distance of this point along x-axis, if I drop a perpendicular from the origin, is x1, and the distance of the point along y-axis is y1. And if I use the geometry of right angle triangle, I can find x1 in terms of r and theta, that is in terms of polar coordinates, and I can write y1 in terms of these two polar coordinates. That is, from this geometry of the right angle triangle, I can write x1 equals r times cos of theta, and y1 equals r times sine of theta. Okay, I may call this equation A and this equation B. Now, what I do, I consider a symmetrical point in the four coordinates of this point. Symmetrical means that now I'm taking clockwise, that rotation, with angle minus theta. This is minus theta because anti-clockwise we take angle positive, clockwise take angle negative, and this is symmetrical to this point if the coordinates of this point are x1 and minus y1. This means if I drop a perpendicular from this point, it exactly meets at that position, and if I drop a perpendicular on the y-axis, it meets at this point, and this is minus y distance. So now if I use this right angle triangle, that is this one, I can again assign values to x1 equals r cos of minus theta, and minus 1 equals r sine of minus theta. I call this C and this one D. Now, if I put the value of x1 from equation A in equation C, I can write r cos theta equals r cos minus theta. Can cancel r on both sides, and that allows me to write cos of minus theta equals cos theta. That is this one result. So cos theta is an even function. Similarly, if I put the value from equation B in equation D, then I can write r sine theta equals r, sorry, I must count this minus the value of y, so minus or cos theta equals r sine of minus theta. Again, I can cancel r on both sides. This allows me to write, and I invert the equation, sine minus theta equals minus sine theta, which is exactly this one result. So sine function is an odd function. This way you can prove that cos is an even function and sine is an odd function. Thanks for watching.